Hi, welcome back to this channel. If you haven't subscribed, make sure you subscribe. That will help grow this channel. It would be better if you turn on the notification bell. That will help the algorithm, the YouTube algorithm, to recommend the videos we have. As always, I'm going to put the link to the Google Colab notes in the description below. If you have any comments or any questions, feel free to leave comments in the comment area. So today we're going to talk about the second lecture in the Laplace transform. The first lecture we didn't really cover much except just the definition of the Laplace transform, and also we did a couple of examples how to calculate Laplace transform for the unit step function and also the Laplace transform of the unit impulse function, right? So that's only two simple ones we calculate. Today we're going to look at the properties of this Laplace transform, and those properties will make the Laplace transform really powerful. We'll see its full-fledged power, the power of the Laplace transform. Also, if you know these properties, you do not need to memorize the Laplace transform pairs, although we have a table. And basically, if you know this, the first two calculations, right? The Laplace transform unit step function is 1 over s, and the Laplace transform unit impulse function is 1. So these two are very simple, and we did use the definition. If you know these two and the Laplace transform properties, all these the formulas, so-called formulas, you don't need to memorize them anymore. So this become very natural to you. Okay, so these the properties are really important. Make sure you understand. So today we're going to cover 4 properties. If you kind of think also 5, because the last properties, the translation properties, include 2. So the first one is linearity property, and this one is really easy, very straightforward, almost doesn't really need much time. And the 2, 3, 4, these are really important properties, especially 2 and 3. These are the secret. That's why the Laplace transform can magically turn the differential equation into algebraic equations, so we don't need to solve differential equations, right? So just make sure you understand those. So let's jump to the first one, the linearity properties. The linearity property is set up like this. So we have the Laplace transform function f1t. We know that's capital F1s, and the Laplace transform. So the f could be any function, right? So we don't have to limit ourselves. Although now we only know the Laplace transform. Up to now, we only know the Laplace transform unit step and the unit impulse. But this could be the any time domain function. Okay, and we find the Laplace transform of, let's see, for constant, for k1 and k2 being constant or constants, if you think this as knowns. And in this case, the Laplace transform, this one would be just based on our definition, that should be 0 to, or to be general, 0 minus to infinity. The whatever the function now, the function is k1 times f1t plus k2 times f2t, right? So these are the function and times the e2 minus st dt. So this is still a definition, right? So this is the time. So this is a time function. And if you carry out this integration, I can write it into 2 integrations. So that's 0 minus to infinity k1 ft e2 minus st dt plus 0 minus to infinity k2 ft f sub 2t, the f sub 1t times e2 minus t dt, right? And if they since k1 and k2 are constant, so we can factor this out. So we can move from the integrand to outside of this integral, 0 minus to infinity f1t e2 minus st dt plus k sub 2 times 0 minus to infinity f sub 2t e2 minus st dt. Okay, so in this case, this one is the Laplace transform of f1, f sub 1s, right? We just defined that one. So this is the Laplace transform of f1t, and this is the Laplace transform of f sub 2t, which is f sub 2s. So the Laplace, so this will be k1 times f1s plus k sub 2 times f2s. And so this is a very simple linearity property, right? So let's see the example here. And let's see, we have ft is, so far we only know the Laplace transform of step function and a unit step function and a unit impulse. So let's see, we have function, let's say 10 times ut and plus maybe 5 times delta t. And the Laplace transform of this one here would be fs is going to be the Laplace transform of ft, and in this case, and that should be equal to 10 times the Laplace transform of ut and plus 5 times the Laplace transform of delta t. And we know the Laplace transform of ut is 1 over s, so we get 10 over s plus the Laplace transform of delta t, that's 1, so that's plus 5. So this is the very simple example utilizing the linearity property. And we'll see the differentiation property and integration property next. So today we're going to have 4 different video clips. See you in a moment.